Would it just be 10 cos 30 is equal to 8 times 8a?
Try that. And you can put it in your calculator and work it out.
So it would be 10 cos 30 is equal to 8a.
Okay, and so a equals?
A is 1.083. That's not look right. Oh no, that is right. Okay.
Great. And the normal reaction?
That's R. So R is equal to 73.4.
Yep. There we go. Okay, so I thought you'd be okay for that one. Okay. How about this one?
Wouldn't the magnitude just be the square root of 10 squared plus 8 squared?
P is 10. You're assuming that it's a right angle in between them. It's 75 degrees.
Oh, is that only when there's a right angle?
Yeah.
Oh, I don't know how to do that then.
So you just resolve it.
Oh, okay. But it says you can do it without resolving into components.
So I would have resolved that, and then worked it out.
Oh, cosine rule. Okay.
Okay, yeah, cosine rule. There you go. So you can use cosine rule because you've got two sides and the angle between. Okay.
How do you find what the direction is?
You would. So you would have to find the cosine rule to get like overall what happens. So. So R, the resultant, is 14.3, and so that's the resultant, and so it's overall going to have a magnitude of 14.3, and then we just want to find this angle.
Okay, with the horizontal. Okay.
Yeah.
Okay.
And so sine rule, sine theta plus 30 over 10.
Because I don't understand how you're meant to know if you need to find the angle or not. Because like I did this question because there's like a maths workbook, and then the answer in that it just said like for the direction it just said like in the y-axis, like it didn't give an angle. So how are you meant to know when to find the direction, when to find the angle?
It sounds like in that case it must have gone straight up, and so they must have just said like in the y direction or something like that, like parallel to the y-axis.
Okay.
In this case you would do sine rule, so sine theta plus 30 over 10 is equal to sine 105 over r.
Okay.
Tricky stuff. So this one's equilibrium. Hang on, let's see if I have another cosine rule thing. That stuff you're okay for, I think.
I can like do it when they give you the diagram, but when you have to draw your own diagram, I think I keep drawing the forces like in the wrong directions, and then I
Yeah.
don't know how to do it.
Yeah. Okay. So this one, what do you know if it's in equilibrium?
Sum of F is equal to 0.
Yeah. And so you would just do that up and down as
Yeah,
well as left and
just
right. Yeah.
mm-hmm.
You could do that using triangular forces. Okay.
That.
So there's no diagram for this one. How about this?
It's still on a horizontal surface.
So like that.
Yeah, it's horizontal, so
You're okay with horizontal stuff?
yeah,
Okay. So
it's like the inclined ones. I'm always drawing the forces like in the wrong place
okay.
or like the wrong angle or something.
Okay, so these are starting with that. Okay, inclined plane.
That's what I.
Yeah, I thought this is the one for you.
So you go, yeah. So the forces on the block is just weight, and then it's sliding down, so there has to be a friction force.
Smooth.
Oh, there's no friction. So then there's just going to be 10G, which is weight, and R. There isn't going to be any other force.
That's 15 degrees. We've got a block 10. And so you have to. So you said what, 10G going straight down?
Yeah.
So that's 10G. Okay.
And
Question.
R
And R.
going. That's it, yeah.
Okay, question B.
Calculate what R is. Okay, so in the vertical direction, it would be 10G cos 15. So R minus 10G cos 15 is equal to 0. So
So
R is equal to 94.66.
I mean, 10G cos 15 is fine, I think.
Okay.
So R equals 10G cos 15. And C.
Sum of F is equal to MA. I'm not sure how to do find the acceleration.
So you said that
Like,
this.
it's F. Wouldn't R and the vertical force going down just be 0? So the sum of F would be 0.
So you said that this force here was 10G cos 15. Any idea what this force here would be?
No.
So this.
Still be 10G.
It would be 10G sine 15.
Oh,
If you were to make a triangle like that, you would have 10G would be the opposite side. This would be the hypotenuse. Opposite over hypotenuse is sine. And so this 10G straight down, you can split it into two parallel and perpendicular Components. This one being 10g cos 15. This one being 10g sine 15.
Yeah.
My diagram's not the best. Okay, so it's going down 10g sine 15. F equals ma.
There's no other horizontal force. Oh, so you just use that, okay. But you know how you drew the sine 15 like on the plane?
Yeah.
I thought you had to draw it like between the 10g and like the 10g cos 15.
Yeah.
That was the sine one.
I mean, it's not my best diagram. We still haven't got an acceleration.
Make like a direct triangle with the force.
Yeah. I'll show you the diagram in a second. I just don't want to show you the answer.
Okay.
Acceleration
Equals 10a. Oh, so a is equal to g sine 15.
Yeah.
Which I can calculate. Which is 2.54.
Okay. 5, 4. And yeah, so in this case it would be like g sine theta, but sometimes you do have friction, and so it's probably best to always just work out everything. So this is their diagram. Okay, so yeah, so straight down 10g. This one here would be 10g cos 15, and then you'd have one there that's 10g sine 15. So all you're doing is splitting up one force into two. Any questions?
But I don't understand how like that one is 10g sine 15. Like I don't understand why. Because I thought it would be like properly like making up the force, and
like
that is making up the force.
Like that?
Well, yeah, it is. Okay. Oh, it is still making up the force. Okay. So you can draw it any way as long as like it makes up the force.
Yeah.
Okay. I did not know that.
Okay, slightly different. How about this one?
Okay. So there's no friction, and you don't know what mg is, so what the mass is, so you can just do mg as the force. And then that force, the 5g one, I'm trying to figure out how to do that one. Oh wait, it would just be like 5g sine 60.
Yeah. That's going up the slope, is it?
Yeah.
And do you know what sine 60 is the same as?
Half? 0.5. No, b over 2.
Oh, I see what you're saying. Yeah, that's fine. Okay, so 5g cos. Wait, did you say sine?
I meant like in the vertical direction, it would be sine.
Okay.
Because it's mg as well in the vertical direction.
So we've got.
In the vertical direction? No, mg is not in the vertical direction. It would be 5g sine 60 minus mg cos 30 equals 0.
Why is it equal to 0?
When you do sum of f, how are you meant to do it when if you add them, you're just going to get 0? So how are you meant to do sum of f? You use the doesn't give you 0? Like,
It's
would you 5G cos 60 because there's no other horizontal force?
there's one other horizontal force
What?
going this way.
No, there's no friction. It says smooth slope.
Would it not be affected though? I mean, if you have mg cos 30, would you not also have mg sine 30 just due to gravity?
Okay, you do. Okay. So you just do 5G cos 60 minus mg sine 30 is equal to ma.
Yeah.
Okay. So you do use the one that's not going to give you 0.
You use the one, what, sorry?
So like when you do sum of F equals ma, you have to use like the forces like in the direction that is not going to give 0.
Well, if it's accelerating, just, common sense, this is the direction it's going to take. It can't go through the ground.
Oh, that's true.
You have to show that it makes this.
You don't know m, so 0.5. Okay. I got m is equal to 4.54, but that's wrong. I think you're just meant to rearrange it and not do it in decimals.
We don't know the acceleration, so.
No, we do. It says 0.5.
Huh.
I don't know how to do this question.
Make m the subject.
I tried that.
Did you bring this one over to this side?
It basically gives you fractions because it's all over half. So I didn't actually do that, but yeah, but then that gives you 10g is equal to 2m plus 2mg. And then you can factorize up 2m. But then you get 10g over. Oh, I guess you could divide both sides. Oh, I got it now.
Yeah.
Yeah, I just did it wrong the first one.
Okay. Yeah, 5g over 1 plus g. So you're just bringing the m's together, factorizing, dividing through.
Yeah.
Yes, so this one, 5g cos 60. In general, mg cos theta going along. And then don't forget the mg sine, I don't know, alpha or something for that one. Okay, how about this thing?
You know these questions where it gives you like what tan alpha or like sine alpha or cos alpha is.
Mm-hmm.
Why is it wrong when you like reverse whatever it is and find the angle? Like why is that wrong? Why are you not able to do that?
It's not necessarily wrong. It's just that it's not as exact. So it's exactly tan alpha is exactly 3/4. If you do
Okay.
inverse tan, then you'll get it to a certain degree of accuracy. But then I think the problem might be if you're doing sine or cos, you'd have to do the cast diagram to check if it's positive or negative, or
Um,
that's kind of
you mean like use the graph, not do the class diagram. I don't like the class diagram.
well, the cast diagram comes from the graph. It's just a summary.
Okay. Got the acceleration. It's moving up the slope. Okay, so it's moving up the slope.
Mm-hmm.
So there's 4n and then minus 2g sine alpha. Would that be equal to, oh, that's equal to MA. So if tan alpha is 3 and over 4, that means the hypotenuse is 5. So sine would be 3/5.
Okay.
And then you know everything, so you can just solve to find. My acceleration is coming out as negative, and I don't think it's meant to.
It just depends on what way you resolve, I believe. So 4 minus 2.
Got A equal to minus 3.88.
0.88.
Yeah.
And you did this one, did you? 4 minus 2g times 3/5 equals 2a?
Yeah.
Let's think about this. Mass, acceleration. 2 times, so g, yeah, that. Maybe event. See? Yep, minus 3.9, roughly. Yeah, because it's accelerating down the slope. There you go. Eventually it's going to start rolling back down.
Okay.
Yeah. Why did you not have to do cast diagram?
Because it's a Pythagorean triple.
Because it's an acute angle, and so it's between 0 and 90. If it was a reflex angle, you'd have to. It would be negative sign.
But also, you don't need to find out what the angle is, so it doesn't matter.
Fair enough. Let's see. Is this worth doing with no diagram?
With no diagram?
Like you said, when they don't give you a diagram, that's the one you...
Oh, yeah. That's one I can't do because I always put in the forces wrong.
Go on. I think you'll be fine, but... Try.
Okay, you know sometimes when it says calculate the magnitude, sometimes it just wants you to find the force, and then sometimes it wants you to do like add and then do the square root. So how do you know?
So magnitude of a vector is just its size. And so let's say if it's horizontal or vertical, its size, its magnitude would just be whatever it is. If it's
Yeah,
diagonal, then you would
even
have to.
forces, sometimes it wants you to find
So
just find out what the force is, and it says calculate the magnitude. Like this one, it doesn't actually want you to find this like at a square root and then like add. It just wants you to find like the value of the force.
I suppose it's just the word magnitude. It just means the size.
Okay.
Yeah.
If the particle is moving at constant speed, does that mean like when all the forces will add up to zero?
Yeah, must mean that acceleration is 0.
Why am I finding? I got F is equal to 14.78 newtons.
And for the friction, 14.78. Yeah, great. Okay. No, hang on.
No, I don't.
No, it's not a good question. I think you're going to be good for those then.
Okay.
I think you're going to be fine. I think you'll be fine. I think you'll be fine, personally. It's a bit weird.
How is it weird?
Just because it's straight up. But other than that, I think it's pretty okay. Making the numbers weirder. Let's see. So then you add in friction. It's probably worth doing. Okay. How about this?
So I got R is 49 newtons. And then since you know that the particle is moving, that means that F is equal to mu R. It's equal to 0.2 times 49, which is 9.8 newtons. The acceleration. So 20 minus 9.8 is equal to 5a. Acceleration is 2.04 meters per second. 9 squared.
2.0, and then that one was 9.8. Okay, that was horizontal. That was my own fault. This is horizontal. I'm going to say that's going to be fine. limiting equilibrium. Okay, slope.
Okay, I can try. I don't understand this. Oh wait, no, I do. It's okay. Okay, I actually don't get this.
How many equations do you know involving forces?
F equals ma.
Any other?
I don't think you can use sum of f equals 0 in this one. But
something to do with friction?
F equals mu r.
You might need both. Let's see. A particle of mass 2 sliding down a rough thing.
I've used both of them, but I still don't know it.
Okay. Between the particle and the slope. Okay, so what forces have you got?
Going up, friction. Oh wait, is there no force acting down? Because I put in a force that's acting down.
What's the force acting down?
No? Is there?
Yeah, what is it?
X. You don't know what it is. Oh, 2g sine 30.
Yep.
Oh, that's right. Okay. Okay, I understand this now. I got confused and put in a random force that's like going down, like another force, apart from 2g sine 30. Because I'm like, I don't understand, because if it has friction, shouldn't it have a force that's going down, like a proper force?
Yeah, gravity.
Okay, so it does not have like another external force that is going down.
Gravity's plenty forceful enough.
Okay. Oh, I can do it now because I already have the equation set up. I just got confused because of the random force. Because I already found what R is and put it in, so. I got mu is equal to 0.46.
looks about right. Mu is always some pretty small number. There you go, 0.46.
Yeah, I just used to put in like random forces.
So this is
Still lot.
2G. So
Yeah.
this must be
I just
2G.
think that I don't think I didn't know that it could just be gravity, like going down. I thought there has to be like a force there.
So this is like, it's supposed to be a real life thing. So if it's a marble, you
Yeah.
let go, it'll slide down. And that's
But it's
because,
sliding. It's not sliding up. Okay.
or roll down, I suppose.
Oh, this is like the same question.
Yep.
Yeah. Oh, I just read this question is like way easier than the other one.
Seems pretty identical.
No, you don't even need to do F equals MA. Or maybe I'm doing it wrong. Who knows?
Oh, go on.
I got mu is equal to 0.27.
0.24. Did you?
Yeah, probably did it wrong.
Ouch. You might have just. Did you round too soon?
No, you do need to do F equals MA. I didn't do it because I thought you didn't need. Because F equals mu R, and you know what F is, and you know what R is, so I don't understand why you can't just divide.
So what are the forces?
Friction, R, and 0.5 G going down. There's no other.
Okay. And so magnitude of R?
0.5 G cos 15 or 4.73. So
Cos 15. This force.
that is 0.5 G sine 15. See, you know what F is as well, so I don't understand why you can't put it to.
And friction?
Oh, you don't know what F is.
No, you do not.
That's why. I'm so bad at this.
So if it was smooth slope, you'd be okay. Rough slope.
So you have to do F equals MA.
Yeah.
So F minus 0.5 G sine 15 is equal to 0.5. Yeah, they wouldn't have given you the acceleration if you didn't need it. Oh. I still got 0.294. I didn't get 0.24.
What did you get for F?
1.395.
And so F equals mu r?
Yeah, I divided it by R. And I got
0.5 g cos 15 mu.
Yeah. But when you divide, you get 0.295 and not 0.24.
They're getting 4.7. What is that?
That's what.
0.5 g cos 15. Okay. F equals ma. Oh, hold on. That's why. It's sliding down.
Okay.
So these two need to be swapped. Friction is the smaller force.
Okay.
So that's going to be minus and that's going to be plus.
I thought the direction that you resolved it didn't matter.
Well, we're about to see if it does.
So it does matter. That makes it more stressful if it does matter. Because our teacher always told us that the maths will fix itself, even if you drew everything wrong. I think I might have done cos instead of sine. One side. How do I get 1.27? I don't even know how. Oh, wait, that is 1.27. Never mind. Okay, now I got 0.24.
Okay.
So the direction does matter.
Sure does. Any questions there?
I don't understand why the direction does matter. Because I thought it would just fix itself no matter what you did. As long as the force is right, even if you got the directions wrong. Okay.
Maybe it's referring to something else, like
Maybe it's
if it's horizontal, yeah, like F equals ma, and just means it's going in the opposite direction. Yes. So we just have to watch out for up or down.
That was kind of hard.
Hmm.
That was quite hard.
Easy peasy.
No. You don't like mechanics. I like it less than stats.
Learn to love it.
No, I'm not going to.
Like an arranged marriage.
No, it's not going to happen. I actually like stats now, though, because I got a good grade on my test. So
That's good.
and we got a new teacher. It's so good. Starting from tomorrow.
Brilliant.
Okay, I know how to do this. I think. You know how you said that along is cos, but it's actually not. I thought along was like cos, but it's not. I got 11.39 newtons. Okay, that's really wrong. I don't know what I did wrong.
Sorry, my thing. Can you hear me?
Yeah.
Sorry. Did you draw the diagram like that?
Yeah.
Did you do P, or was it P cos something or P sin something?
No, it's just P.
Okay. This force?
F.
Could you be more specific?
You are.
Is it...
Wouldn't P be the friction force? No, never mind. Because it's moving down the slope. The acceleration is down, and it says it's sliding down.
Yep.
So wouldn't P be equal to F?
All
right.
This force?
Yeah.
2G... what is it? Sine 20?
Yeah.
And this...
So there is no friction force. That's not right. There has to be a friction force.
So then we'll chuck in... let's see, it's sliding down. So that means friction will be acting in this direction?
Oh, that's where I went wrong. I put F the other way.
Go on, try it again.
Because honestly, I don't know how to do this.
Yeah, you're doing great.
No, I'm not.
So it's literally just a direction.
No, I'm still gonna get like P is equal to 1.2 or something, which is wrong. So it's still wrong. Let's just start all over again.
So which way is it sliding down? Sliding down, okay. Is equals to 2. Is it minus 2a?
You know what a is, and why would it be minus 2?
Because if we these two are plus, or I could just flip the whole thing around.
Yeah, I did 2g sine 20 minus f minus p, but I still got it wrong. So
2g sine 20 minus p minus f equals
I think I might have calculated f wrong, but I'm not sure how because I got r right. So
a is 0.2, so 2 times 0.2.
yeah. Did you work out what f is? I mean, not what f or r is. Sorry.
Is that 2g sine 20?
Yeah, that's what I thought.
Sorry, 2g,
No, I got
2g cos 20?
That's what I got as well. But I feel like I might have calculated the friction wrong because it doesn't work with anything.
2g cos 20.
It doesn't work when you put it in to this equation. It still gives you a wrong answer, so I'm not sure why. Because I got friction equals 5.09 because I did 2g cos 20 times 0.3 because that's what mu is. And that gives you 5.52. Okay, right, I did calculate the friction wrong. How did I put it wrong?
Mu r.
I'm getting 0.77 now.
Yep. Yes. Great. Any questions there?
No, I just keep making mistakes in everything.
So it's just getting the right way. Yeah, it really is. Just the thing. So when they give you the diagram,
Like I know how to do the maths, but like I don't know.
So I think your only thing, so you've done it all really, is if it is you're traveling down, then friction would act against it, and vice versa. And so that's the only thing you really need to watch out for. Yeah. No one likes them anyway. How was that for you, Amogha?
Okay, a bit hard, but it's not like super hard.
Anything in particular you want to do next time? We could do the other forces.
Integrate probably.